In this video, we're going to take a look at common reactions of alcohols. Now, the first reaction is one of my favorites, combustion reactions. So a combustion reaction is where we take an alcohol, we react it with oxygen and produce carbon dioxide and water. So an example of this is the combustion of methanol. In this combustion reaction, we're taking methanol, reacting it with oxygen to give us carbon dioxide and water. So this is a combustion reaction. Another type of chemical reaction with alcohols is a intermolecular dehydration reaction. And what does that mean? Intermolecular means within one molecule. Dehydration means removing water. An example of this is if we have a 3-carbon alcohol, such as propane. And I'm not writing in all of the hydrogens here, but there'd be a hydrogen here like this, okay? And there'd be other hydrogens on here. I'm just being lazy and I'm not drawing them in. Now, in this dehydration reaction, you might have a strong acid as a catalyst, such as sulfuric acid. And with this, we're going to remove water. So when we remove water, we're going to end up removing a hydroxyl group and a hydrogen. These two will come together and form our water. So over here, I'm going to have water. That came from right here. And then when I remove water, I'm going to take these covalent bonds and I'm going to bring them together and make a double bond. Like that. Now this reaction gets a little bit tricky if our hydroxyl group is not on the end like this. So, for example, here I have 2-butanol. And I didn't write in all of my hydrogens, but there would be a CH3 here, and a carbon hydrogen here, and we would have a CH2 here, like this. Now, in this reaction, we're going to remove a hydroxyl group and a hydrogen. So we're definitely going to remove this, okay? So I'm going to put that over here. Here's my OH. And then the question is, which hydrogen comes off? Do we take one from here, or here, or here, like this? Where is that going to come from? And so my products, what are my products going to be? Now, for this one, we could end up then removing, say, this hydrogen and ending up with a double bond here, or hydrogen up here and ending up with a double bond like this. And the question is, which one's going to be favored? Which one would actually happen? Now, to predict this, we have a rule. This one's called Zatev's rule. Zatev's rule tells us that the hydrogen we're going to remove comes from the carbon atom that has the fewer hydrogen atoms. So for example, this carbon atom has 3, this one has 2. And so we're going to remove hydrogens from the atom that has the fewest hydrogens here, and so it's going to be this one here. So we're going to end up removing this hydrogen, and we'll end up removing this hydroxyl group. So that means our double bond will end up here. So here we'll end up with water plus a double bond there. The next type of chemical reaction we're going to take a look at is an intermolecular dehydration reaction. Intermolecular is a little bit different in that it has 2 different molecules that we're going to join together by removing a water. So let me draw out the structures here first. Okay, here I have two molecules. And notice that they have these substituents on them. Here I have an OH, and here I have an OH, okay? And we're going to remove water. We're going to remove water and join these two together. So I'm going to use the same catalyst here, a strong acid, such as sulfuric acid, and I'm going to remove a hydrogen from one of these. So remove a hydrogen from one of these and an OH from the other, and then join them together. So when I do this, I end up with my products. Now our products here are going to be water and joining these two together. This next type of chemical reaction is called an oxidation reaction. But before we figure out the oxidation reaction, there's something we need to recognize, and that is primary, secondary, and tertiary alcohols. So what makes an alcohol primary, secondary, or tertiary is where the hydroxyl group is on the alcohol. So for example, if I have this molecule here, this one here is 1-propanol. One propanol has 3 carbon atoms, 1, 2, 3 carbon atoms, with an alcohol attached on it like this. This one is called a primary alcohol because the carbon atom here that the hydroxyl group is attached, this carbon atom is only attached to one other carbon atom. I know you're thinking, oh, but there's a whole chain here, there's 2 of them. Yes, but this one here is only directly attached to one other carbon atom. So we would call this one a primary alcohol. So we do like a 1 and then a degree symbol like this, meaning that this is a primary alcohol. Now a secondary alcohol like this here is 2-butanol. Butanol, this hydroxyl group is attached to a carbon atom that has 1, 2 carbon atoms directly attached to it. So this becomes a secondary alcohol. And then the last one we have here is a tertiary alcohol. So a tertiary alcohol would look like this, where we would have a carbon atom here attached to 1, 2, 3 other carbon atoms. This would be tertiary. Okay, so why do we differentiate primary, secondary, and tertiary alcohols? And the reason for this is because in oxidation reactions, it depends what type of alcohol is involved and what kind of product we'll end up with. For these oxidation reactions, we're going to use the same catalyst, and this is permanganate. This is MnO4 minus. And what we'll end up doing is we'll end up removing hydrogens. So as we take a look at this here, if we remove a hydrogen from this, if we remove this hydrogen, we're going to end up with an extra covalent bond. And that extra covalent bond is going to bond with the oxygen and this carbon atom here. So we'll end up then with this. Like this, where we have a carbon double bonded to an oxygen. Now that's going to be a little bit different with this one here. With this one here, we're going to end up removing the hydrogen, but we're going to end up with the double bond in a little bit different spot here. So now instead of the double bond oxygen being on the end like we saw here, notice that this hydroxyl group here is on a secondary carbon. So on the secondary carbon, we're going to end up then with our double bond like this, coming off of that secondary carbon. And then the last one down here, this is our tertiary alcohol, and we end up with no reaction. no reaction. Now, the reason this is important is because these are two different products, two different structures here. We have a double bond on the end, and here we have a double bond kind of in the middle here on this secondary alcohol. And using oxidation reactions, using this permanganate, we can differentiate primary and secondary alcohols based on the products that we would have. And we could also differentiate potentially tertiary alcohols because there would be no reaction. So if we have an alcohol and we want to know whether or not it's primary, secondary, or tertiary, we could try doing an oxidation reaction.